Hello everybody and welcome back to our videos on learning how to program in Unreal Engine 4 using C++ programming language. In this video, we are going to talk about memory management in Unreal Engine 4. In particular, we need to look at how memory management is handled in programming languages such as the C++ programming language. And in general, when we are allocating variables and memory containers, our compiler would either utilize our operating system to automatically reserve and allocate memory, or we will need to allocate the memory ourselves. So in the first type of memory allocation, you basically create variables and you won't get access directly to the location, but the content of those variables through your operating system. But sometimes you might need to allocate memory yourself in terms of dynamic memory allocation when you need to, in runtime, decide how much memory you need and then make that request. When things like that happens, you would end up requiring to either manage your dynamically allocated memory yourself or rely on a system that allocates the memory for you and manages these memory allocations. So in this video, we are going to look at how you can allocate unmanaged memory, basically utilizing malloc or free functions in the C++ programming language, or the use of the new or delete operators. And these would give rise to unmanaged memory. So the programmer, when we're referring to an unmanaged memory, the programmer would require to keep track of the memory allocations and then deallocate the memory appropriately. In Unreal Engine 4, we have a system in place that manages the memory for ourselves. So when we have dynamically allocated memory that does not have any pointers to it, or pointer locations aren't being used, the system will be able to figure that out and then delete or remove those memory allocations so that you would not end up utilizing all the memory available to your program. And this is basically managed memory system. Then we'll see how Unreal Engine keep track of these objects, and also how you can create and use shared or smart pointers, basically, that will track memory for you. And then finally, we'll look at the garbage collection in Unreal Engine 4 and how you can utilize it by using the uProperty macro. And whenever you have memory locations that you don't want to manage yourself, you can tag them with the uProperty macro and make the UE4 engine to go ahead and perform the allocation and deallocation for you. And if we have the time, towards the end of these videos, we are going to take a look at how you can utilize the debugger to find bugs in your program, or to utilize the profiler to see how performance of your program is utilized. Okay, now that we've gone through an introduction about basics of memory that is managed and memory that is not managed, let's take a look at how unmanaged memory works. Managing memory is always one of the most important things that you need to handle efficiently in effectively any computer program to run properly. And in order to have a bug-free and efficient program, you need to be able to either work with your memory yourself as a programmer, or rely on a system that handles the memory management for you. As I said, so first thing we want to do is we take a look at unmanaged memory and see how it works. There are two ways in C++ that you could dynamically allocate memory. And these two ways are effectively the same, with the small difference that I'm going to talk about. The first way that you can allocate dynamic memory is to use the malloc function. It stands for memory allocation, and whenever you create a pointer for either a native type or an object that you created, or any kind of abstract data type that you created yourself, or are relying on third-party programs that have created, you could utilize the malloc function to allocate the memory. When you are allocating memory with this function, the only thing that you need to remember is that by default, the constructor of your objects are not going to be called. And so if you are actually using abstract data types and objects, it's best to use the new operator. The new operator creates the memory in your looper. The new operator creates a block of contiguous memory and associates that zone to the use of your program. And it also calls the constructor of any object type that you are utilizing in order to create the allocation of your objects in memory. Once you allocate the memory, you can work with the content of this memory by the dereferencing operator, which is the star symbol. However, when you're done with the block of memory and you no longer need this block of memory, you will have to dynamically deallocate it. And the deallocation can be done by calling the free function if you allocated the memory using the malloc function, or to use the delete operator if you have allocated the memory by using the new operator. So the malloc and free go together, and new and delete will go together. Next, we'll take a look at seeing how it actually works. Okay, now let's see how you can utilize the malloc and free functions to allocate dynamically your memory and then to deallocate it when you don't need it. So let's suppose that we want to assign a jump height to our character. So when we press the spacebar, as you have seen in the previous videos, the character jumps, and now let's hypothetically suppose that we want to change the height of this jump. So one way that you can do that is, and here I'm actually declaring a pointer variable so that you see how working with pointers work, and so we'll see the allocation and deallocation. Obviously, since it's just only a simple integer, we might not need a pointer for it when we just create a simple variable. But hypothetically, let's say that we do want to assign a pointer. So first, in the first line, we declare our pointer variable, which is called jump height, by typing int pointer jump height. So the star character, the star symbol here, is the symbol for a pointer variable. In the second line, we are allocating the memory for this pointer. So what happens here is we basically call up the malloc function, and the malloc function takes in the size in byte of the amount we want to create. So here we pass size of int as a parameter to our malloc function, and then we cast the allocated memory into an int pointer. So you see inside the parentheses I have the int pointer. That's basically casting the amount of allocated memory to be an int pointer, and we assign that to the jump height. If you wanted to work with the content of jump height variable, pointer variable, you would have to utilize the dereferencing symbol, which is the star symbol again. So we type in star jump height equals 10. What happens here is that the amount 10 is going to be placed in the content of jump height. And then in the fourth line, I'm actually creating a text that just simply shows that the player jumped this amount in the air, and then I'm logging that content into the log temp of my UE4 log. And if this is not familiar to you, basically you can watch a couple of videos ago that shows you how you log text and variables onto the output log of Unreal Engine 4. Once you're done with your pointer, you would have to deallocate it. So at the second to last line here, I'm done with the jump height. I don't need to use it anymore. So I'm going to call the free function on it, and it deallocates the memory for me. And an extra cautionary step, I'm going to also assign the value 0, which is the null pointer, to jump height. This basically makes the pointer to point to the 0th address, or the beginning address of your memory, and it is a safe address to use because your operating system will not allow you to do anything with it. So later on, if you accidentally wanted to put values into jump height, you would get an error. So this is how the malloc and free functions work, with allocating the memory for you and then deallocating it when you are done with it. With the new and delete operation, almost entirely the code is going to stay the same with the exception of the allocation line and the deallocation line. So in the allocation line, I'm going to call the new operator on my object, which is of type int. So if you have an int pointer called jump height, when you want to allocate it, you say new int. And as I said, the new operator will also call the constructor of your object. And so here the integer construction will be called up. We again can just simply place the amount 10 into the content of the jump height by dereferencing it, and the dereferencing is done by the star pointer, as you see here. And then once you're done with the pointer and you want to deallocate it, you simply delete it. So you say delete jump height, and it deallocates your memory for you and calls up the constructor, or rather the destructor of your object. And finally, you set the jump height to be null so that you would avoid accidentally working with this pointer later on. So you simply can, whenever you want to work with this pointer, you just put it in an if statement to test to see if this pointer is null or not. And if it is not null, you can go ahead and work with this pointer. So this is how the unmanaged memory works in C++, either by the new and delete operator or by the malloc and free functions. Okay, as we said, working with unmanaged memory is a little bit tricky because whenever you create and dynamically allocate memory for an object, either using the malloc operator or the new operator, you would have to remember to delete it whenever you don't need the pointer any longer. Otherwise, you will have dangling pointers in memory left available, and therefore the operating system will not be able to utilize that memory until your program execution is finished. So to avoid this, Unreal Engine has a layer on top of the regular memory allocation system, which basically works with managing your memory. And the idea here is that there is a system in Unreal Engine that is on top of the lower level memory allocation and deallocation framework that takes care of counting how many objects of a certain pointer type are available, and then whenever the count comes to 0, meaning that the object that is allocated is no longer in need, it will be passed to the garbage collector to basically flag it for deletion and then delete it whenever the garbage collection operations run. There are two ways that you can work with the managed memory allocation in Unreal Engine if you wanted to use Unreal type object classes or Unreal type classes. Two of the most useful class types that are available for you to utilize are obviously the UObject class and the AActor class. The UObject class is any object that will have any kind of logical representation for you, but you don't necessarily need to have any kind of physical representations in the game. So for example, if you want to represent actions for your player, you can use them as UObject classes. So you derive your object from UObject, and then you can work with this. If you wanted to utilize these objects as some sort of physical representation in the game, for example, to assign to them meshes or textures or materials and things like that, that have visual and physical representation, the best option is to go with the AActor class. And the AActor class is basically an object class that also has physical representations for you. So if you wanted to work directly with the memory management in UE4, you utilize either a UObject or an AActor class. You derive from these two classes, either one of these two classes, and then your objects are going to be reference counted, which means that the garbage collection will take care of deleting them whenever the number of references of these objects in your game drops to 0. Now, once you create a class derivative of either a UObject or an AActor class, you can dynamically allocate these objects by utilizing the new object constructor or the construct object constructor functions on UObjects. And if you're using an AActor derivative, then you would be able to utilize the spawn actor to be able to spawn an object in the game, and therefore having a reference to it. And then you could destroy it by using the destroy actor to delete it. Now that we have learned about managed memory and unmanaged memory and the pros and cons of each of these types of memory systems, basically either utilizing the new/delete operators or the malloc/free functions for allocating your own memory for your object and classes by manually, or if you wanted to utilize directly the UObject class type or the AActor class type to create default UE4 managed memory classes and objects, we now start looking at how we can go ahead and utilize these objects and basically how you track these objects in memory. If there are certain pointers that you want to allocate, but you don't necessarily need to utilize either a UObject, a full-blown UObject, or a full-blown AActor, you can still make this pointers effectively memory managed by utilizing the U property. So in the next video, we are going to look at how you can utilize memory management in UE4 and track your objects in memory.